In southern Italy, 500,000 people are living on land that should not exist, a city built inside the mouth of a monster. Right now, the ground beneath their feet is swelling, lifting entire city blocks inches into the air every single year. They live, work, and sleep on a thin crust of earth, separating them from a chamber of magma that is actively pressurizing, getting ready to break. By 2026, the earth has been shaking for years, not with a single catastrophic earthquake, but with thousands of smaller tremors, a constant grinding that signals a system approaching its limit. This is not a theoretical danger, not a problem for the next century. This is a geological crisis happening right now. Scientists have set a deadline. A peer-reviewed study, published in April 2026, warns the volcano is approaching a critical mechanical transition, a point of no return. They predict it will be reached between 2030 and 2034, just a few years from now. So the Italian government did something unprecedented. They drafted an evacuation plan for a metropolis, a protocol for emptying a city of 500,000 people at a moment's notice. But here's what they didn't tell you. The ground is fracturing faster than their models predicted. In 2025, an artificial intelligence discovered that the bedrock was breaking apart along thousands of hidden fault lines, 4 times more seismic activity than any human had ever detected. 4 times closer to failure, while the world watches Yellowstone, the famous American supervolcano, for signs of doomsday. Another monster, older and more active, is waking up, and it's doing it directly underneath a major European city. So the real question is, are we watching the right volcano? Or are we staring at a sleeping giant in Wyoming, while the real catastrophe is quietly building in the heart of the Mediterranean? Campi Flegrei was never supposed to be this dangerous. The name itself, from the ancient Greek, means burning fields. For centuries, it was a place of myth and wonder. A landscape of steaming fissures, bubbling mud, and sulfurous air rising from the crater of Solfatara. The Romans built their villas here, drawn to the thermal baths and the fertile volcanic soil. They unknowingly settled a caldera, a vast, sunken volcanic depression 12 kilometers wide. This was not a single mountain with a single cone. It was a sprawling, decentralized system of dozens of vents and craters, most of them hidden beneath the city of Naples and the waters of the Gulf of Pozzuoli. By every standard of geology, this was not a safe place to build. It was an active volcano, and yet civilization took root. Today, the city of Pozzuoli sits directly in the center of the caldera, a dense, coastal port of 80,000 residents. Move outwards, and you find the red zone, the area of highest risk, home to 500,000 people. Just beyond that, the yellow zone, with another 800,000. All of them live within reach of a volcano that has erupted more than 70 times in recorded history. All of them are part of a geological experiment that has been running since the end of the Roman Empire. The defining feature of Campi Flegrei isn't just eruption, it's breathing. The ground itself inhales and exhales in a phenomenon known as bradysism. Deep underground, magma chambers and superheated hydrothermal fluids fill and empty, pushing the surface up or letting it sink. The evidence is carved in stone. In the city of Pozzuoli, the ruins of an ancient Roman market, the so-called Temple of Serapis, stand as a permanent record. Holes drilled by marine mollusks halfway up its marble columns prove, with physical certainty, that the entire structure was once submerged deep in the ocean and then violently pushed back up onto dry land. The city itself has been rising and falling for millennia, but the breathing is getting faster, more violent. Between 1982 and 1984, a massive bradyseismic crisis lifted the port of Pozzuoli by 1.8 meters. The ground cracked, buildings fractured. 40,000 people were forced to evacuate. After a period of quiet, the ground started rising again in 2005. It has not stopped. The current phase of unrest has already lifted the city by another 1.4 meters, nearly 5 feet. The Italian National Institute of Geophysics and Volcanology, the INGO, monitors this movement in real time. Their sensors track every millimeter of uplift, every tremor in the rock. In 2012, as the uplift accelerated and the micro-earthquakes multiplied, they raised the official alert level from green to yellow, from normal to attention. It has remained there ever since, a constant, official acknowledgement that the system is no longer stable. And the signs of that instability were getting worse. On May 21, 2026, a magnitude 4.4 earthquake, the strongest in decades, struck just offshore in the Gulf of Pozzuoli. It was part of an intense seismic swarm, thousands of small shocks that sent residents into the street. It was just the latest jolt in a crisis that had been escalating for years, a crisis that scientists were beginning to realize they had fundamentally misunderstood. The shaking was only half the story. The other half was what the scientists were not seeing, what their instruments were missing. For years, the Ingor's Vesuvius Observatory, the oldest volcano observatory in the world, had been tracking the swarms of tiny earthquakes that accompany the ground uplift. The seismic network was state-of-the-art, capable of detecting thousands of events across the caldera. The number was already alarming. The consensus was that the crust was being stressed by the rising pressure from below. And then, in September 2025, a team from Stanford University and the INGI decided to look again, not with human eyes, but with an artificial intelligence. They fed a machine learning model years of raw seismic data, the faint, continuous background noise that traditional detection algorithms were programmed to ignore. The AI was not looking for clean, classic earthquake signals. It was looking for patterns hidden in the static. What it found changed everything. Buried in the data from just 2022 to 2025, the AI uncovered 54,000 hidden micro-earthquakes, more than 4 times the 12,000 that standard tools had cataloged. These were not random tremors. They were organized, clustered, and tracing out massive, previously unmapped fault lines running directly beneath the most densely populated areas of the caldera. The ground was not just being stressed, it was breaking. It was fracturing on a scale that no one had realized. William Ellsworth, a Stanford geophysicist on the project, put it plainly. These long faults suggest that an earthquake in the magnitude 5 range is not out of the question, he said. We've known that this is a risky place for a long time, and now we're seeing for the first time the geologic structures that are responsible. A magnitude 5 earthquake underneath a modern city is a destructive event. Underneath Pozzuoli, a city already being stretched apart from below, it could be a catastrophe. But the AI discovery pointed to a more immediate and unpredictable threat. In April of 2026, INGI officials made a critical announcement. The ongoing uplift, the ground swelling that was lifting Pozzuoli into the air, was not just being driven by hot water. It was being driven by the accumulation of fresh magma, deep underground. Their models confirmed a sill of magma growing at a depth of 7 to 8 kilometers, pressurizing the entire system from the bottom up. That magma acts like a gas burner under a sealed pot of water. It heats the vast hydrothermal system trapped in the rock above it. The water turns to steam. The pressure builds. The greatest short-term risk at Campi Flegrei isn't a river of lava. It is a phreatic explosion, a violent, instantaneous blast of steam, water, and shattered rock that happens when that pressurized underground water finds a sudden path to the surface. It happens with zero warning. No lava, no ash cloud, just a catastrophic detonation from below. The AI had just revealed thousands of new fractures in the rock. Thousands of potential pathways for that steam to escape. The system was not only more pressurized than anyone knew, it was also more broken. While Italy was wrestling with a volcano breaking apart in real time, the world's attention was focused elsewhere, on a geological superstar 8,000 kilometers away, Yellowstone. The name itself is a brand, a synonym for supervolcano, for global catastrophe. It is the villain of countless disaster films, the subject of breathless documentaries, the source of a constant, low-level hum of internet doomsday speculation. The caldera spans 85 by 45 kilometers across Wyoming, Montana, and Idaho. A footprint so vast it's only visible from space. It is a true monster. The Huckleberry Ridge Tuff eruption, 2.1 million years ago, ejected 2,450 cubic kilometers of rock and ash. The Lava Creek Tuff eruption, 631,000 years ago, was responsible for another 1,000 cubic kilometers. These were planet-altering events, burying continents in ash and triggering volcanic winters. And the internet has a favorite word for it: overdue. Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, has spent his career fighting that single word. Overdue can apply to library books, bills, and oil changes, he states plainly. But it does not apply to Yellowstone. Volcanoes do not operate on a schedule, and even if they did, the math is wrong. The interval between the first and second major eruptions was 800,000 years. The interval between the second and third was about 670,000, an average of roughly 725,000 years. Based on the last eruption 631,000 years ago, even this flawed schedule would suggest it is not due for nearly another 100,000 years. The modern Yellowstone is active, extraordinarily active, but its activity is not eruptive. The ground breathes, just like at Campi Flegrei, rising and falling in slow, predictable cycles as the magma chamber deep below shifts. But it does so on a continental scale, over years, without the frantic, violent energy seen in Italy. Its most visible features are hydrothermal: the geysers, the hot springs, the bubbling mud pots. These are the signs of a powerful heat source. They are not signs of an impending eruption. The official alert level for Yellowstone is green, normal. The U.S. Geological Survey maintains one of the most sophisticated monitoring networks on the planet there, tracking seismicity, ground deformation, and gas emissions. They see no evidence of magma moving toward the surface. None. The volcano's last magmatic eruption wasn't a super-eruption at all. It was a comparatively gentle rhyolitic lava flow that created the Pitchstone Plateau, some 70,000 years ago. Since the last super-eruption, Yellowstone has had around 80 of these smaller, non-explosive events. It is a quiet giant, a system operating on a geological timescale that is almost impossible for humans to comprehend. Thousands of years between events, and yet it captures the public imagination completely. It is the decoy, the spectacular, terrifying, and ultimately dormant threat that distracts us from the one that is moving right now, the one whose pulse is measured in months, not millennia, the one with a deadline. The deadline arrived in a scientific journal. In April 2026, a study led by researcher Zaccagnino and his colleagues modeled the relentless ground uplift at Campi Flegrei. They weren't just measuring how high the ground had risen, they were measuring the rate of change, the acceleration. And what they found was that the crust was no longer behaving elastically. It was no longer just bending, it was starting to break permanently. Christopher Kilburn, a volcanologist at University College London and a pioneer in this work, confirmed the finding. Our new study confirms that Campi Flegrei is moving closer to rupture, his team reported. Parts of the volcano had been stretched nearly to breaking point. The Zaccagnino paper went a step further. It calculated when that breaking point might be reached. It modeled a regularized finite-time singularity, a mathematical term for a system approaching a catastrophic failure. Their models predicted Campi Flegrei would hit this critical mechanical transition, the point where the rock can no longer absorb the strain, sometime between the years 2030 and 2034. This was no longer a vague hazard. It was a forecast, a ticking clock counting down not to an eruption, but to the moment the ground itself fails. The failure could manifest as a larger earthquake, or it could create the pathways for a phreatic explosion, or it could, in the worst case, signal the beginning of magma's final ascent to the surface. It was a warning delivered in the dry language of physics that the volcano was entering a new and far more dangerous phase. How do you evacuate a metropolis? This is the question that now dominates every meeting of Italy's Civil Protection Department. The plan exists. It is detailed, color-coded, and rehearsed. The red zone, 500,000 people, must be cleared within 72 hours. They would be moved by bus, by train, by car, along designated escape routes to host regions across Italy. The yellow zone, another 800,000 people, would face catastrophic ashfall and would need to shelter or evacuate depending on wind conditions. The logistics are staggering, an operation on a scale that has never been attempted in modern Europe, and it all hinges on a single decision: the shift from a yellow alert to orange. Yellow is attention, orange means pre-eruption. It means an eruption is likely, or potentially imminent. An orange alert would trigger the mandatory evacuation of the red zone. It would mean telling 500,000 people to abandon their homes, their jobs, their lives, based on seismic data and mathematical models. It would mean shutting down a major part of the Neapolitan economy, based on a forecast, not a certainty. The pressure on Lucia Pappalardo, the director of the INGS Osservatorio Vesuviano, and on the civil protection authorities is immense. Move too early, and you cause a panic and economic disaster for what might be a false alarm. The volcano could quiet down again, as it has before. Move too late, and the consequences are unthinkable. The 1982-84 crisis, which lifted the ground higher and faster than the current one, did not end in an eruption. But the physics are different now. The AI has shown the ground is more broken. The models show the strain is accumulating. This is not 1984. This is the fundamental difference between the two supervolcanoes. Yellowstone's risk is statistical, a low probability, high consequence event that could happen in 1,000 years, or 100,000. Its scale is continental. Its timeline is geological. Campi Flegrei's risk is mechanical, measurable, and accelerating, a high probability event on a human timescale. Its immediate consequence is the destruction of a city. The last time magma reached the surface here, in 1538, the eruption was considered small, a VEI 3. It lasted 8 days. In that time, it created a new mountain, Monte Nuovo, 130 meters high. A small event at Campi Flegrei is a city-altering catastrophe. The plan is in place, the science is getting clearer, the ground is still rising, and the clock is still running. But none of it is enough to answer the most urgent question. The question of when. An eruption is not an inevitability. Not yet, but the conditions for one are assembling faster than anyone thought possible. The magma is there. The pressure is building. The rock is breaking. And all of this is happening in plain sight. In a place that has been settled for 2,000 years, a place where history and geology are so deeply intertwined you can no longer separate them. The final irony may be that the world's most dangerous volcano isn't the one hidden away in a remote American national park. It's the one we built a city on top of. Yellowstone sleeps. It is a problem for our descendants, for a future we can barely imagine. Campi Flegrei is awake. It is a problem for this decade, for right now. The AI keeps listening to the groans of the earth beneath Naples.